The system we're going to discuss next is called ToMM. ToMM is short for Theory of Mind Mechanism. ToMM allows us to infer the full range of mental states from people's behavior. It also provides us with a systematic theory of mind that allows us to make sense of people's behavior in terms of internal, unobservable mental states. In consequence, the first function of ToMM is representing the full range of mental state concepts, and not only volitional, perceptual, and affective, as the previous subsystems do, including SAM. Among other things, ToMM allows us to represent epistemic mental states. Just as a parenthesis, the adjective epistemic roughly means related to knowledge. The second function is integrating our knowledge of mental states into a coherent understanding of how mental states and actions are related, so that this knowledge can be turned into a usable theory of mind and action. So let's talk about the first function of ToMM, which is to extend the range of mental states representable by the individual. And let's discuss one particular class that Baron-Cohen himself focuses on, which is the class of epistemic mental states. Epistemic states include states like belief, knowledge, hope, suspicion, and many others. This coincides with a category of mental states known in the philosophical literature as propositional attitudes. A proposition is something that can be believed or disbelieved, or expressed by a sentence in a particular language, or that can be used in logical inference. In English, a proposition can be introduced by the conjunction that. So you have the proposition that snow is white, the proposition that grass is green, etc. These states are called propositional attitudes because they consist of an attitude, say belief, desire, hope, etc., towards a given proposition, such as that snow is white. So you can have different attitudes towards the same proposition, such as the belief that snow is white, the desire that hope be white, and so on. Likewise, you can have the same attitude towards different propositions. You can believe that snow is white and also believe that grass is green. Epistemic states, as examples of propositional attitudes, are characterized by the phenomenon of referential opacity. What does that mean? Here's an illustration. You may remember that there is a moment in Snow White in which she's given an apple by an old woman. It just so happens that the old woman is the evil queen in disguise. But Snow White doesn't know this. So with this situation in mind, let us see the difference between referential transparency and referential opacity. Let's start with a case of referential transparency. Suppose that it is true that Snow White touched the woman selling apples. Then, when you combine this with the fact that the woman selling apples is one and the same as the wicked queen, you have to conclude that Snow White touched the wicked queen. So if Snow White touched the woman selling apples is true, then Snow White touched the wicked queen must also be true. This shows that the verb touch creates a transparent context, because if you have a true sentence, and if you replace the phrase referring to what is touched with a phrase that refers to the same thing, the resulting sentence is also going to be true. So if something is being touched, then something is being touched, period, independently of how we think and talk about it. Now consider the predicate think. Suppose that you agree with the truth of the sentence, Snow White thinks that the woman selling apples is a good person. Then, even if you combine this with your knowledge that the woman selling apples is the wicked queen, it is in fact false that Snow White thinks that the wicked queen is a good person, because she doesn't know that they are the same person. And this reflects the fact that the predicate think creates an opaque context. If you have a true sentence, and if you replace the phrase referring to what is believed with a phrase that refers to the same thing, then the resulting sentence is not necessarily going to be true. So whether you believe some proposition or not, it is going to depend on how things are being referred to. It depends on how we think and talk about it. It depends on whether you think of the same woman as the evil queen or as the good lady selling apples. In sum, a predicate like touch creates a referentially transparent context, since the truth of the sentence in which it appears is independent of how its object is referred to or represented. However, a predicate like thinks, and indeed like believes, hopes, fears, wants, is referentially opaque, since the truth of the sentence in which it occurs will depend on how the relevant objects are represented. And so, thinking, as opposed to touching, can be crucially affected by misrepresentation, as in the case of Snow White and the old woman with the apples. This phenomenon may sound complicated when you lay it out in explicit detail. However, small children, once they reach a certain age, have no problems with it. For instance, normal 4 to 5-year-olds understand and enjoy tales of deception and mistaken identity, such as those in Snow White and many other children's stories. And this seems to indicate that they have a grasp on the notion of representational opacity, and of the corresponding possibility of misrepresentation. So now, how does ToMM encode the referential opacity that characterizes epistemic states? In this respect, Baron-Cohen basically incorporates Leslie's account of meta-representation, which we saw in a previous video. If you remember, Leslie's account is based on the notion of M representation. Well, according to Baron-Cohen, what ToMM outputs is precisely M representations. An M representation, if you remember, expresses a relation between an agent, an attitude, and a proposition. For example, the agent slot can be filled with mom, the attitude slot with thinks, and the proposition can be it's raining. And this will yield the M representation mom thinks it's raining. Or you can add different values to get Al hopes Al gets a toy. Or in the case of Snow White, the child will form the M representation Snow White thinks the apple lady is good. Notice that in M representations, propositions are enclosed in quotation marks. This means, in Leslie's terminology, that they are quarantined by means of decoupling. If you recall from our discussion of Leslie's model, decoupling involves copying primary representations of objects into a working memory type store where they can be manipulated without the constraints of reality, so to speak. Representations are thereby detached from their usual implications and functional profile. This decoupling process allows children to understand that mental or any other representations can either reflect the world truthfully or falsely. For example, as when Al thinks he is seeing a fish when he's actually seeing a mammal. Thus, given that the propositions that are embedded in M representations get quarantined by means of decoupling, the whole representation can be true, even if the embedded proposition is false. Thus, this sort of representation allows the child to entertain the possibility that, even though the apple lady isn't actually good, Snow White thinks that she is. So, M representations allow the child to consider the possibility of misrepresentation. And in doing so, they enable the child to incorporate referential opacity into its conceptual system, which is a requirement for understanding epistemic states like propositional attitudes. Notice that the capacity to countenance misrepresentation seems to be one of the requirements for passing the false belief task. In order to successfully represent someone else's beliefs, you must be able to consider the possibility that they may diverge from reality. And in Leslie and Baron-Cohen's accounts, typical children are able to do that by deploying M representations, which are usually an indication of a maturing theory of mind. Okay, the second of ToMM's functions is tying all the mentalistic knowledge that the person has into a systematic and workable theory. But first of all, you may be asking yourself, why call the knowledge that children have about minds a theory? Aren't we perhaps over-intellectualizing the child's mind? Baron-Cohen relies on Henry Wellman's arguments to defend the view that the knowledge that children have is indeed something like a theory. Of course, it's not an explicit theory, like a theory formulated by a scientist, but rather an inexplicit set of assumptions that manifests itself in patterns of thought and action. One reason for assimilating the child's mentalistic knowledge to the category of theory is that, from the age of 3 years, children have an adult-like ontology. You can think of an ontology as an inventory of the basic categories of things that there are. And this ontology divides the universe into mental and physical entities, where each category has systematically different properties. For example, children know that a real physical cookie can be eaten, whereas a thought about or dreamt of cookie cannot. Another observation is that children use their mentalistic knowledge in highly theory-like ways. They use their knowledge about perceptions, beliefs, desires, and intentions to predict and explain action. So in this illustration of Wellman's scheme, they would reason from left to right to predict behavior, and they would reason backwards from right to left to provide explanations. Finally, children seem to tacitly abide by a series of axioms, basic laws, that form the basis of a theory. Among them are seeing leads to knowing, appearance and reality can be different, people are attracted to things they want, and others. So now let's take stock by comparing Tom with Sam and the rest of the subsystems we've seen so far. First of all, ToMM only fully emerges by the age of 4, though it starts developing much earlier. It is farther upstream from sensory systems than the other 4 submodules, so its input profile is amodal and form-independent. However, what is more characteristic of ToMM is the variety of the mental states it can represent, and its signature output in the form of M representations.